The next person on our list of people to talk about, astronomers to make a talk about in history of astronomy, is Sir Isaac Newton. And you think of that and say, wait a minute, I've heard of Newton. You know, he invented the fake Newton, right? No, no, he didn't. Okay, but Isaac Newton, you have heard about. Everybody's heard of Isaac Newton. And he studied gravity. Now, we don't normally think of him as astronomers. Well, astronomers think of him as an astronomer, but other people normally don't think of him as an astronomer. But he really did study gravity. And so he became very important here in our studies of the sky. And so he was born actually Christmas Day in 1642. And when he was old enough, he went off to college. Okay, went to Cambridge and was going to study theology. And again, in those days, when someone went to study theology, they studied math and they studied science. They studied science to understand creation. They studied math because it's a good discipline for the mind. And so while he was doing this, he was studying some of the discoveries that had been made in Europe. By the middle 1600s, they had already agreed that Galileo was right, and they had agreed that all the planets go around the sun. They also had agreed that Kepler was right, and all the planets have elliptical orbits that speed up and slow down, and p squared equals a cubed. That was all accepted science. And so he was learning how all this works, and studying math and the new work by Leibniz and Riemann from mainland Europe. And then a pandemic hit. I'm sure many of us can relate. Okay, so here he is in college working on his degree, and a pandemic hits. The plague. Now, they didn't really understand all the details of how the plague worked, but they did know that where lots of people were, lots of people died. And so they did what has been done since ancient times. When there's a pandemic, they shut everything down. So they closed down the university and they sent everybody home. And they said, anybody who's still alive in 2 years, come back. Okay. They did not have computers, internet, or remote learning. Okay. But this is what you do. Okay. So they shut down the university and everybody sent home. So Isaac Newton went home. While Isaac Newton was at home, he was sitting around thinking about things, thinking about the stuff that he'd been learning, and kind of watching squirrels jump from tree to tree. So we got a tree here, we got a tree over here, and we've got this squirrel here. Okay. Forgive my lack of artistic ability. So that's a squirrel. And so the squirrel wants to jump from this one tree to the other tree. And so how does the squirrel do that? Well, the squirrel does that by launching off this way. And he started looking at that, and he says, when the squirrel jumps, the squirrel pushes down on the branch, and that pushes the squirrel up. Once the squirrel is up in the air, the only thing pulling on the squirrel is gravity. So the horizontal motion doesn't change. The up motion becomes down motion because gravity is pulling down, and so the squirrel follows this big curved path. Mathematically, you can show that the path is a parabola. When the squirrel reaches this other branch, then the squirrel is going downwards, but in order to stop going downward, it has to be pushed upwards. That push corresponds to a push downward on the branch. And so he starts looking at that and says, the bigger the squirrel, the bigger the branch gets pushed. And so he realizes there's certain relationships here. That there's a relationship between the change in velocity we call acceleration, and the mass of the squirrel and the force. So he comes up with 3 laws of motion. An object at rest or moving does not change its motion unless a force acts on it. An object at rest remains at rest, or if it's in motion, it moves in a straight line at constant speed unless a force acts on it. An object's force is proportionate to the mass and the acceleration, and for every force, there is a second and equal and opposite force. Now, putting that in simpler terms, because what I just said it was kind of what the book says. Things either stay put or they move in a straight line and they exert a force on them. In space, you have a spacecraft moving along, you cut the engines, and then nothing happens. It just keeps moving in a straight line. It doesn't change motion unless a force acts on it. F equals ma. This is Newton's second law of motion, and for every force, there's an equal and an opposite force. So you push on one thing, it pushes back. So these become very fundamental laws of motion. So in my physics class, we cover these laws of motion, and we can start solving problems for how things move. Mathematics. In fact, the math becomes kind of robust, and Isaac Newton realizes that solving all these physics problems is difficult. So what he does is he invents a brand new branch of mathematics to make solving problems easier, called the calculus. And so calculus makes solving physics problems a whole lot easier. And that's kind of an interesting thing, because I sometimes teach the college physics, which is non-calculus based, and I often teach the university physics, which is calculus based. And so a lot of people think, well, calculus is a higher level of math, so it's going to make the physics more complicated. Well, actually, it actually is a lot simpler. Algebra is harder than calculus. And so if you know calculus, it makes solving the physics problems way simpler. He comes up with what we call the universal law of gravitation. He says, if I get two masses, mass 1 and mass 2, they have a force between them. That force depends on mass 1, depends on mass 2, depends on the distance between, and this g in front, that g in front is called the universal gravitational constant. That's just a constant. The constant is given right down here. Okay, it's just a number. So you multiply that number times mass 1 times mass 2, divide by the distance between squared. That gives you the force between two things. All you need to have force is mass. You get mass, you get force. Okay. The moon has mass, so the moon has gravity. The moon has less mass than Earth, so there's less gravity on the moon. You weigh about 1/6 of what you on Earth. So if you have an astronaut that with their spacesuit on weighs about 600 pounds on Earth, because those spacesuits are very heavy. So the astronaut plus spacesuit 600 pounds, but on the moon they only weigh 100 pounds. And so that's how the astronauts were able to move around the moon with big, heavy spacesuits, is that they only weigh 1/6 because the moon has less mass and therefore less force.